5, 4, 3, 2, 1.
My name is Dion Knights. I'm from Trinidad and Tobago, and I'm a hydrologist or hydrogeologist studying groundwater surface water interaction in coastal environments. I've always been interested in science from a young age. I kind of saw myself as a scientist, and when I got to high school, we had a lot of different science classes that they had us take, like chemistry, biology, physics. I kind of discovered earth science, which was something kind of like right in the middle, where I could apply chemistry, physics, and biology to things that were easy to see and observe. I like to think about things that get near the ocean, but not quite in the ocean, right at that interface between the land and the sea. So where you'd probably picture a beach. Those things could be small particles that can have effects on water chemistry and physics and global temperature and stuff like that. I currently work on how the chemistry of water is influenced by wetlands or estuaries near the sea. And the reason I think about those things is because a lot of people live at the sea, live at the ocean, live on the coast. We use that water for recreation, we use it for industry, for fishing. And the health of the ecosystems in those environments are very important for a lot of different people and a lot of different industries. I do a lot of work at deltas. There are these land masses that sort of grow right at the end of like rivers. What you will find is that a river carries water, but not only water, it carries a lot of different things, including sediment. There's a lot of sediment flowing in rivers. And in order for that sediment to be transported, the river needs to be flowing really, really quickly. Once you get near the ocean, the river slows down and it's no longer able to carry that sediment load. So the sediment actually deposits in different formations, and sometimes they form deltas where the one main river channel sort of splits up into a bunch of different smaller river channels. And I look at how those systems in particular influence some of the other things river transports. In the water is called nutrient transport. We did some field exercises in the Arctic. We went to Okiavik, Alaska, and we did some experiments. So we added some nutrients into one of the streams, and we wanted to see how quickly the nutrients were removed. It's essentially just the flow of nutrients, those little chemicals that are important for life in rivers. What you would find with climate change and temperature rise is that the discharge increases due to melting glaciers and thawing permafrost, which means that the flow of nutrients is a lot faster. And nutrients can therefore get from land to sea rather quickly without having time for the deltas to do what they do and remove some of them. Sea level rise is an interesting one. Depending on the amount of nutrients you have entering into the ocean, that can affect the amount of photosynthesis you have, and that could also affect the temperature of the ocean.